Hi guys, Shouvik here. Welcome back to our YouTube channel. So today we'll solve another question from Leetcode they are providing us. So let's get started. Now on today's question, we have a check if grid can be cut into sections. So now let's try to understand the problem statement first. So they have given an integer in representing the dimensions of a n cross n grid. So they have given the 2D, mostly they are going to give some 2D matrix. The dimensions of that is n cross n. Now with the origin at the bottom left corner of the grid. Now our origin, that is 0, 0, is lying at the bottom left corner of the grid. You are also given a 2D array of coordinates rectangles where rectangles I is the form of start x, start y, index end y, representing a rectangle on the grid. Each rectangle is defined as follow: start x, start y, the bottom left corner of the rectangle, index end y, the top right corner of the rectangle. Now note that the rectangles do not overlap. Note that the rectangles in the given configurations, what's the rectangles they have given to us, it's non-overlapping. In the initial configurations they are non-overlapping. So this point you have to take notes, because the entire intuitions of this particular question lying on these statements only. Initially the rectangles are not overlapping. Initially the rectangles are non-overlapping, and your task is to determine if it is possible to make either to horizontal or two vertical cuts on the grid, such that each of the three resulting sections, by two cuts, how many sections you are going to build? 3, because the number of pieces after cut is number of cut plus 1, because if you cut something in from middle one cut, there are 2 pieces it is going to divide. So it's as intuitive as I told. So by one cut you can generate 2 pieces, 2 sections. So they basically asked you have to make 2 cuts, and by 2 cuts it will generate 2 sections, 3 sections, that is for sure. And each of the 3 section formed by the cuts contains at least one rectangle. Now the cuts you have made in the n cross n grid, which is provided initially, every sections, how many sections you have? 3 sections, and every sections should have at least one rectangle. You have at least one rectangle, and every rectangles belong to exactly one sections. You can't make a rectangle to a part of section 2 and section 1. No, you can't. You have to make a rectangles to a part of one section, complete one sections, to fit the rectangles to a one sections. You have 1, 2, 3 sections, 1, 2, 3 sections. You have to fit them to a particular sections only, either by horizontal cut or either by vertical cuts. You can make two horizontal cuts, and you can basically put the rectangles, all the rectangles to all the 3 sections you have created after the cuts, or you can make vertical cuts. You can put all the rectangles given to you to the vertical cuts you have built. But there are two constants. The rectangles belong to exactly one sections, and every sections after the cut, it should hold at least one rectangle, and return true if such cuts can be made, otherwise return false. So I think the question is very simple and straightforward, and if you are not able to understand, then obviously by test case iterations you guys definitely get the gist. So here you can see we have a grid of size 5 cross 5. So here you can see its terminal point is 5 cross 5, having start point as 0, 0, which is bottom left, and one rectangle, this yellow rectangle, starting from 1, 0, its x-axis at 1 and y-axis at 0. So starting from 1, 0, and its top right corner grow to 5, 2. So here you can see it's grow to 5, 2. Another, so that is one rectangle. Another rectangle is starting from 0 to 2. So this is 0 to 2 and end at 2 to 4 here. Another rectangle starts from 3 to 2. So that is of 3 and 2 and end at 5, 3. Another is 0, 4 and 4, 5. So now on this, if you can make a cut, if you can make two horizontal cuts at y2 and y4, then you are obviously make all the rectangles to part of the sections, 3 sections, and all the sections contains at least one rectangles. So now you can see that I think I have named the variable something on reverse order. So let me just quickly correct it out. So verticals, we are cutting on verticals and horizontals. So verticals should go to these, that is verticals, because verticals we are cutting on XP we are cutting verticals. So yeah, else I think we are good. And on horizontal pay we are naming it as verticals, 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 verticals. That's it, right? And on horizontals we are doing horizontals, 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 and horizontals. Cool. Then we are doing this verticals, horizontals. Mostly I think we are good. I'm just like as per the question I named them reverse, so yeah, it's still working fine. We also try to submit. It should work, it should work. Yeah, it's working fine, there is no issue. Yeah, so now let's understand, continue on the problem statement itself. So the first discuss, I guess, clear to you. I named the variables in reverse, so that may create some confusion. So as per the questions, you can see, like if we make a cut to y-axis, it is considered as a horizontal cut, right? So I actually renamed it on reverse. So this cut I considered as a vertically we are cutting, so I named it. So so it should reverse. So as we making the cuts to the horizontal, it should be horizontal cuts, right? So now you can see, so this is clear, I guess, to you guys. And on this test case, you can make two vertical cuts at x2 and x3, and with the given test case you should be able to fit all the rectangles, given rectangles, to at the part of three sections you have created, and each section should hold at least one rectangles. But with these test cases, you can draw it, and you are not able to make the condition satisfy. There can be any reasons. We cannot make two horizontals or two vertical cuts that satisfies the condition, since output is false, right? So now just seeing the questions, what is the intuitions on your brain? Like on very first go, it is quite difficult to like think, because there are x-axis, y-axis, and there are like multiple things actually coming to the brain. But there is a clue. That is basically these things. You can make either two horizontal cuts or either two vertical cuts. So this line, but actually I am get the hints just by reading this line only, this group of words only. So I am pretty sure my x cuts by this line. I am pretty sure that my x cuts, or you can say my vertical cuts, cutting through x is considered as a vertical cuts, is independent of my horizontal cuts, is independent from my horizontal cuts. So that is actually the intuitions, that if you catch these intuitions, then the question is like a cakewalk for you. So my vertical cuts is independent from horizontal cuts, and my horizontal cuts is actually independent from my vertical cuts, so that is actually the beauty. So now if we can go to the go to our OneNote. So how I am going to state these things, two are independent. So if you are trying to understand the things like this, so let's suppose this fine, can I write? No, allow yaar to me write. Yeah, so let's suppose we have that, I am first considering in horizontal cuts. Let's suppose we have these things. So now let's suppose we are making a cut at index y1. Let's suppose we make a horizontal cuts at y1 to entire right at what is the in value is given to us. Before going to that, let's me just quickly iterate you guys to the constraint. So n can grow 10 to the power 9, so we can't iterate on n, and rectangle's length can grow to 10 to the power 5. So here you can at max apply n or n log n type of things, and this is very intuitive. Like rectangles of I0 and rectangles of I2, they are under the range of 0 and 10, and rectangles of I1 and I3, they are also in the range of 0 to 10. I think that is very intuitive. And this point, no two rectangles are overlaps. I will tell you how it is actually going to build your solutions. This is going to build your solutions. So let's suppose you have a cut at, I am making this actually y double dash, and let's suppose I create some little more space create हुआ है क्या? हो गया. So now let's suppose that is our 0, 0, and let's suppose that is our boundary. So let's suppose consider this place is our boundary, and we are making cut at y1 y dash and y double dash. So let's suppose we make these two cuts. One is y dash and y double dash. Now tell me how you can say that this is a valid cut. This is a valid cut. So if I am interested to make a cut at y double dash, when I am going to not able to perform these operations, when I am not going to perform that particular operations, if any particular rectangles, having something like this, if this is a particular rectangle, which I am highlighting, if this is a particular rectangle, then can we make a cut at y double dash? Can we? Nope. Why so? Because on the question it is clearly stated every rectangle should be part of a one section. So it is a part of partially on these sections and partially of below sections. So that which is not allowed. So a cut to y dash, is only valid when there is not a single rectangles which actually have its if I consider as y1 and if I consider this as an y2, if we are cutting at y1, so y1 less than y2 and it is belonging y double dash. Actually, let me write it clearly. So y1, y double dash and y2. If that is the case, so that means I made a cut at some points where I am basically through a middle of a rectangle I am cutting it. So that is not allowed. So if we are doing a cut something like this, then we are obviously violating our that principle, that is one rectangle should be part of one section. So no. So these conditions should not hold. So which conditions can hold? So initially also one condition is there, that is every rectangle should be part of that every section should contain at least one rectangle. Every section should contain at least one section. So if I sort, so let's suppose let's forget about x part. So let's suppose we have only y axis. Let's suppose we only have this y axis. We have only y axis and we have to make two cuts on it. 0, 0 is there. And let's suppose we have rectangle. Let's not consider it's rectangle. It's x axis. You can negate. Let's suppose it is not a rectangle. Let's suppose it is just a stick. Stick only have y axis. So that is one stick for sure. Now on here you can have multiple sticks. So sticks I am meaning that it has only vertical axis. On x axis it has 0. So it has no breadth actually. Breadth, or I can say more clearly, breadth equals to 0. Only it has height. So that is, let's think these things for initial things, then I am going to explain how if we have breadth, then also our answer is not going to change, because we can process x and y axis independently. So now let's understand these particular things. If you understand these things, then next part is just a cakewalk. You can just solve it like on few seconds only. So just focus on these particular sections. Now what is actually, if I am super greedy, then what I will do? So we know we have some sticks. We have some sticks like this. So and now we make a partition which basically group the sticks to a section, and every section should have at least how many? At least one stick. Now first solve this particular question which I just told. We have sticks only have y axis. We make the sticks in a part of a section such that every section should have at least one sticks and a particular stick is not going to part of two sections. So here you can see this section has 3 sticks. This section has 1 stick, and this section also has 1 stick, right? So now the thing is that you always have to put the very first who is very bottom line, who is at very bottom line, you have to put a sticks on this particular thing is for sure, right? And now because every section should have at least one stick, so initially you can do what you can do. Now I think the question is very straightforward. So now you can do your sticks. Let's suppose I have sticks. Sticks is every sticks has its y1 y2, then y1 y2 y1 dash y2 dash, then your next sticks, let's suppose y1 y2 y1 dash dash y2 dash dash. So every, and let's suppose you have another sticks at y1 dash 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 y2 dash dash dash, something like this. So if the question is something like this, you don't have x altogether, you have only sticks. Now what is the very greedy things you can do? What is the very greedy things you can do? Can you tell me this? Can you tell me this? If we sort these things, if we sort these things, right? If we sort these things, then what is going to be happen? So everyone is going to be sort by its starting of y1. Everyone is going to be sort by its y1 index. So it is bound to be y1 less than y1 dash less than y1 dash dash less than y1 dash dash dash. So if we sort this, so these conditions is always valid. So, or more specifically I can write it as less than equals to. So these conditions is always valid, and we know our y1 is always like y2. Actually y2 is always greater than y1. Y2 is always greater than y1 because we have some height, we have some height, at least one height for every rectangles, right? So now you sort them. So the very first rectangles which is lying at the or the sticks, I have to say, for the sticks I have to say, which is at the very first, which is occur at the very bottom line, very close of the bottom line, very close of your horizon, should have come first. And what its end. So in this example, where it's gone, yeah, so here you can see what its end. So this particular point, can I say its end? Or here, if I do the sort, then y2 value, can I say it's as an end? Can I say it's as an end? So now if I have these sticks and I have to make these vertical cuts, if I have to make the vertical cuts so that the conditions that I told you is valid, so that the condition is going to be I told you as valid, and every section should have at least one stick. So let's suppose what I will do, I will put the very last very bottom line, which is very close to the bottom line, its last index, I will store this as a last boundary. I am going to store as y2. We are going to store y2. Now if I'm going to store y2, now y1 dash, now I know there is a sticks from y1 to y2. I know there is a sticks, and next sticks either start from here, y1 dash either start from here, or so if I can make a boundary here, if I can make a boundary here, and if my y1 is starting my, what is the y2 value? So we have y2 value at, let's suppose on some y3. Let's suppose some y3. So or y2 is fine. So if my y2 value is greater than my next one, that is of y1 dash dash. So the very next sticks after sorting is greater than. So that means that my very last index, or the end, or I have to say, or more specifically I can write it as an end. If my end is greater than my y1 dash is greater than my, sorry, not that dash dash, it is y1 dash is y1 dash. So can I say these two particular sticks I am not able to make any cut. We are not able to make any cut because there is no way I can make a cut, because on either case stick 1 or stick 2 is part of two sections, which violates our theorem, question theorem, right? So what is then valid? What is the valid when we can then make the cut? If very simple, if I have my y1 here, y2 here, and if my y1 dash starts from, so if that is my boundary, if that is my boundary, so if my y1 dash, that is the very next sticks start is either from y2 or above of y2, so my y1 dash should be greater than equals to my y2, if that case is valid, can we make a cut at y2? Yes, obviously we can make. So now I think this question is boiled down to very simple problem. So now after sorting these sticks, if we can make the cut, if the last sticks found index or what is the end we have? Still now how many sticks we have considered, and out of them all of the sticks last, which is going to be pointed by this end variable, is going to be stored by this end variable. If my new sticks which I am considering now, if its start is more than, or more specifically I can write it as an end, if my new stick start, that is of y2, sorry, not this as an end, this should be y1 dash only, and this y2 actually I can write this as an end if I can rewrite this thing. So y1 dash, so that is of the current stick start is greater than equals to my global end means how many sticks I have considered so far, all of its extreme right boundary, all of its extreme up boundary. If my new stick starts is just equal or above, I can sure shot make a cuts from this point. Right? So I can make a cut on this. So if like this way only we can make the cut. If we can make the cut, and at any point of time we are able to make cut equals to 2, like this way. So I already told how you can consider it as a valid cut. So that is our condition. Valid cut conditions is this. And if you are able to making these conditions true, if you are able to make two cuts, then from there only you can return your answer as true. Right? As simple as that. And now let's consider if x-axis, if I considered if as a not a sticks, if I consider is an rectangle, do our answer change? Because we are processing both the axes independently. So when we are y, so x, if I have a rectangle at here, there is no chance there is a rectangle with overlapping at this particular y section, because the question is altogether stated on initial configurations, no two rectangles overlap. So when I am considering these particular sections, so when it is going to be overlap, if there is a vertical overlap, just we saw, but if there is a horizontal, if on x is there is a rectangle, so let me write it on the clear sections. If let's suppose we have these sections, right, and let's suppose we have a rectangle here on section S1, S2, S3, right, and let's suppose we have a rectangles here, and is this condition is ever valid? No. So that means on the initial configurations the rectangles are overlapping, right? As simple as that, right? So these conditions is altogether not valid. So on initial configurations it can be what it can be this and something like this, and something like this. Then on that case your this boundary, that is your y1, that is your y1, sorry, that is not dash, and that is your y2, and that is your y1 dash, that is your y2 dash, right? That is your y2 dash. And what is your extreme end? If your end should point to what is the maximum till now you have considered. So when you are landing at this particular rectangle to consider is, can we make a cut? So how we can do? So if I can say if my end is y2, so end is y2 only. If the current start, if my current start is y1 dash, if that is greater than equals to, so that is our condition, right? That is, I think I wrote at different place. So that is our condition, right? If that condition is valid, no, for our case it is not valid, because our end is at y2 is greater than yn. So that means on the vertically they should both belongs to the same, they should belong to the same sections. We can't make a cut and make this all together rectangle to a separate section. No, we can't, because it is under the boundary it starts, that is of y1 dash is under the boundary of the last seen rectangles, last seen rectangle end. So if that is the case, then we are not make a cut and make these particular rectangles to a part of a different sections. Nope, we can't do. So it is as simple as that, guys. It is as simple as that. And I have explained for your horizontal cut, like on y-axis cut, and you have to do the exact same business to the x-axis cut. You have to do exact same copy paste code to the like x-axis part or the vertical cut. So now let's go to the code altogether. We can iterate the codes and we can obviously understand. I written it in a very simple manner. So initially we have verticals and horizontals to list, and I have created the list because I want to process them in the independent manner. Verticals I will process by verticals and horizontals I will process with the horizontal list. Both are independent. Why independent? I just explained. So I have considered, when I am making horizontal cuts, I have considered is a stick. I have altogether neglected the x-axis. I have altogether neglected the contribution of x-axis, and I am able to build the answer correctly because on the initial configuration there is no two rectangles are overlapping. I am not going to repeat the things. If you are not able to understand at any point, please go through, please stop here and please like basically re-go the particular sections. You will definitely get this. But yes, this is obviously a master level question. I have to say it is more than a medium level question. Like identify these things is very tricky. Like we can process verticals and horizontals. So that is obviously a master level question. So that is, I am understanding that if you are not going to consume in the first group, please go to the video 1 or 2 times, the one note explanations that we just did. So please go to that part 1 or 2 times. You will definitely get this. Now I am iterating on the rectangles they have provided, and I am pushing on horizontals cut pe what we have to push, y values, y1, y2 we have pushed, and on verticals pe what we have to push, x1, x2, and I am increasing the size. So size basically provide me how many rectangles they have provided. So I am also maintaining a size counter so that I can get the size there on. And initially I did horizontals.sort. Like what is the horizontal axis we have? Horizontal axis we just explained on the y1, y2, y1 dash dash, y2 dash dash. So for every rectangles we are pushing y1, y2, and for explanations I told you like every rectangle has y1, y2, next rectangles should have y1 dash, y2 dash, third rectangle says y1 dash dash, y2 dash dash, something like this. And we sort them to the y1 value, sort them by the y1 value. And I put, already I told the end that we just mentioned here, the end things. End is basically global end, like all the rectangles till now we have visited. What is the very last visited? What is the very last visited we have? So that is basically on initially we have very last visited at, after sorting, what is the very last, what is its endpoint, what is its y2 value, what is its y2 value, what is its upper value, like sticks upper value. So if we, I think that is very intuitive, you guys getting this. And we have starting our cut at 0. I have started our cut at 0, and I am starting iterating from index equals to 1, not index equals to 0, because for index 0 we have already processed that. I have already considered there is a rectangle, and post that I have started processing, because every section should have at least one rectangle. So we bound to put the very first rectangles after sorting, horizontal sort, the very first rectangles to the first section, that we bound to do. So I am iterating from index 1, and by chance, so that is our y1 dash value, if you remembered. So that is our y1 dash value. If our y1 dash value is greater than equals to the last visit, that is our end. If that is the case, so can I say we are able to make a cut, right? And what we have to do, our last visited should be max of last visited, and the current rectangles last value, the y2 value, y2 value we have considered, because on last visited we are basically storing the global last, all the rectangles we have considered, what is the maximum extended right one rectangles have at one rectangle. So the new rectangles should have equal or more values. If that is the case, then only we are able to make the cut on that particular point. And if like this way, if we are able to cut 2 cuts at any particular time, then obviously from that points itself we can return a true. And I have did exact same code. If I can minimize this, so here you can see so this is horizontal, and here you can see I have just changed the variables. Ideally you don't have, you basically avoid somewhere writing like this. You can pass these things to a method in a single method with the arguments at different. So one you can pass horizontals list, and another functions calls you can pass as a verticals list. So in interview definitely try to do so, but for quick implementations purpose I did it. But for interview you will definitely segregate the, if both are identical, then segregate these things to a common function and pass this, like control this entire logic to a function call with different arguments. You definitely do this in interview. But here you can see I just tweak the variables name. I just make on horizontals I have put only verticals, and I am successfully able to build the logic for verticals also, and this means, and if we are after processing horizontal, after processing verticals, if we are still not able to return a true, then we can finally return a false. So that means there is no possibility of making two horizontal or two vertical cuts, So yeah, man. So this question is as simple what you just seeing right now after the entire explanations, and yeah, and here you can see I am doing a sorting. Horizontal sort and vertical sort. So here you can see some lazy sorting I am doing. What I am doing? Lazy sorting. What is actually lazy sorting? So I am first sorting horizontals and I am trying to build the answer. So if by horizontal sorts we are able to build the answer, then I can say my verticals loop is altogether not going to be executed. So verticals loop is altogether not going to be executed, and vertical sorting is altogether not going to be executed. That's the for sure. So that actually called lazy sorting. So yeah, actually on industry you listen these things more, where lazy initializations, lazy propagations. So this is actually like help you to run your code like more optimizedly. So I am only doing vertical sorting if horizontal cut we are not able to build the answer. So vertical when we need. If by horizontal by chance we fail, then why you process verticals at very first? So you maybe see, or maybe you have done also the same mistakes, that on initially you have sort both horizontal and vertical, but is it making any sense? Why are you hitting your code with n log n complexity unnecessary? So if we are making our code by horizontal sort only, then altogether vertical processing we need? No, we don't need. So segregate the function call, segregate them, so that like you can only invoke these particular sections if our horizontal things is not together build the answer. Yeah, man. Yeah, the question is as simple as that, and if you are able to understand, I think you are on the very good state. And I have to say that is a master level question to identify these things like horizontal or verticals can be processed independently. So yeah, now quickly discuss our time complexity part. So on time complexity, what we are doing, we are basically iterating to our rectangles. That is obviously taking for sure big O of n. Then I am going to give you the worst case time complexity. Let's suppose we are not able to build the answers. Then on that case, we will iterate this, and we will do the two sortings also. And basically, two sortings are going to take big O of how much? Plus big O of, tell me, big O of 2n log n, right? 2n log n. Let me name this as n, 2n log n. So this n actually not this n, man. So let's not confuse with this n. So this is actually rectangles dot length. I am again telling that this n, the capital N which we are writing on the test cases, is basically rectangles dot length, which can grow at by as 10 raised to the power 5. And we are doing iterating 2 times on verticals and horizontals. Maybe when we are returning false, then on that case we are going to do the entire things that we have written. The entire things is going to be written. So that is again going to be a 2n for one for vertical and another is for horizontal. So that is the time complexity, guys. Actual time complexity. You can state on the interview on very high level perspective that is your solution is big of n log n, but try to give it as granular as possible. If you are giving your time complexity something like this, so the interviewer is completely fan of yours. Definitely, I have to say, because you know each line executions how much time your code is going to be take. And on space perspective, we are using one vertical array and one horizontal array. And apart from that, are we using anything? No, we are not using anything. So we are playing with variables only. So on space complexity, I have to say that is a big of 2n for sure. Yeah, guys. So that is the most optimal time and space complexity which I am able to find out. So if you are able to understand still this point, so I guess you know what you guys have to do. You have to subscribe to our channels and share the videos to your friends who are actually preparing for the interview. So like explaining this particular question is very challenging for me. Like I am almost sweat out because it is obviously a master level question, and the intuitions which actually need to solve this particular question is very trivial. And if you are able to understand till this point, and if you are following us till this point, please do subscribe to our channel. Please turn on the notifications so that when we are going to be live with the next video, you are going to get the video as soon as possible. So that's it, guys. That's it for today. Bye, guys. Bye. Let's meet tomorrow with another video.